Hi there! This time I will have a brief discussion about the nature of electromagnetic waves. Electromagnetic waves are one of the waves that are propagated by simultaneous periodic vibrations between electric and magnetic field. It is a disturbance in a field that carries energy and does not require medium to travel. Electromagnetic waves are formed when an electric field comes in contact with magnetic field. It is produced by a charge that changes its direction or speed. Electrons are charged particles that can produce electric and magnetic fields. Electromagnetic waves are transverse in nature. That means that electric and magnetic fields change or oscillate in a plane that is perpendicular to the direction of the propagation of the wave. Longitudinal waves, on the other hand, are waves consisting of a periodic disturbance or vibration that takes place in the same direction as the advance of the wave. The wave movement is parallel to its direction. Example of longitudinal wave is a sound wave. Electromagnetic waves do not need a medium to propagate. It travels at the speed of 3 times 10 to the 8 power meter per second in a vacuum or an empty space. The energy carried by magnetic electric fields in an electromagnetic wave is equal. The speed of light in a vacuum, commonly denoted as c, is a universal physical constant important in many areas of physics. Its exact value is defined as 299,792,458 meters per second. For the benefit of the doubt, light from the sun travels around 150 million kilometers to Earth in 8.3 minutes. Electromagnetic waves are typically described by any of the following 3 physical properties: frequency, wavelength, and amplitude. Amplitude is the maximum displacement or distance moved by a point in a vibrating body or wave measured from its equilibrium position. Frequency is the number of waves that pass a fixed point in unit time, also the number of cycles or vibrations undergone during 1 unit of time. So we have here in our figure, the uppermost example is a low frequency wave, and the one beneath is the high frequency wave, and the one at the middle is a medium frequency wave. Wavelength is the distance between corresponding points of 2 consecutive waves. So we have here in our example, wavelength, the distance from crest to crest or trough to trough. When we say crest, that is the highest point of the wave, and trough is the lowest point of the wave. Frequency and wavelength are inversely proportional to each other. The wave with the greatest frequency has the shortest wavelength, and the wave with lowest frequency has the greatest wavelength. Because all light waves move at the same speed in a vacuum, the number of waves crest passing at a given spot in 1 second is determined by the wavelength. So we have here a sample problem. Calculate the frequency of green light from a traffic signal whose wavelength is 4.25 times 10 to the negative 9th power meter. So our given are, the c is constant, or the speed of light, that is 3 times 10 to the 8 power meter per second. And we have the wavelength represented by the symbol lambda, that is 4.25 times 10 to the negative 9 meter. And we are looking for the frequency of the green light of the traffic signal. So we have here the formula: frequency is equal to c over wavelength. So let's substitute the value: 3 times 10 to the 8 power meter per second divided by 4.25 times 10 to negative 9 meter, and that is 7.1 times 10 to the 16th power hertz. So that is our frequency. The development of electromagnetic theory was credited to the following scientists who took part in the history of electromagnetic waves: James Clerk Maxwell. About 150 years ago, James Clerk Maxwell, an English scientist, developed a scientific theory to explain electromagnetic waves. He noticed that electrical fields and magnetic fields can couple together to form electromagnetic waves. He assumed that light is an electromagnetic wave. He is also responsible for the classical theory of electromagnetic radiation, describing electricity, magnetism, and light as different manifestations of the same phenomenon. He formulated the electromagnetic wave theory, which says that oscillating electric current should be capable of radiating energy in the form of electromagnetic waves. He discovered that a changing magnetic field will induce a changing electric field, and vice versa. Heinrich Hertz, a German physicist, applied Maxwell's theories to the production and reception of radio waves. The unit of frequency of radio wave, 1 cycle per second, is named Hertz in honor of Heinrich Hertz. Hertz proved the existence of radio waves in the late 1800s. He used two rods to serve as a receiver and a spark gap as the receiving antennae. Where the waves were picked up, a spark would jump. Hertz showed in his experiments that these signals possessed all the properties of electromagnetic waves. Michael Faraday is probably best known for his discovery of electromagnetic induction. He was the first to produce an electric current from a magnetic field. He also made fundamental contributions to the electromagnetic theory of light. He was the first to produce an electric current from a magnetic field. He also invented the first electric motor and dynamo. It was largely due to his efforts that electricity became practical for use in technology. The standard unit of capacitance is named in his honor, farad. André Marie Ampère. He discovered that magnetism could be produced without magnets. He also discovered that wire carrying electric current can attract or repel another wire next to it that is also carrying electric current. He was generally regarded as one of the main founders of classical electromagnetism. The standard unit of electric current, ampere, is named after him. He also played a key role in the development of galvanometer and coined the term for solenoid. Hans Christian Ørsted, a Danish physicist and chemist who discovered that electric current create magnetic fields. He was a professor in Copenhagen University, and during his evening lecture in April 1820, he discovered that a magnetic needle aligns itself perpendicularly to current-carrying wire, a definite experimental evidence of the relationship between electricity and magnetism. A vertical wire carrying an alternating current will generate an electric field. When current flow in a coiled wire called solenoid, it acts as a magnet. A solenoid with a core of iron acts as a strong magnet. The electric field in turn generates magnetic field, whose change generates electric field. This succession of induced fields results in the propagation of electromagnetic wave. Hi guys, if you like my video, please hit the like button and subscribe, and don't forget to hit the notification bell to get updated on more videos on my channel. This is Sensei Jenny, your learning buddy.